Part B then, we need to show that AB has the equation x plus 3y minus 7 equals 0. And we also need to find the equation of CD, so I'll have to sketch that as well. So I've written them out here. Equation of AB, show that it's equal to that. And find the equation of CD, which we'll put in a minute. So, but first of all, let's do the equation of AB. We know the gradient of AB is minus a third. So here, y equals mx plus c. The gradient is minus 1/3 for that line, isn't it? The line AB, so let's write that down. And we know that it's going to go through the point 2 minus 3 and 10 minus 1. So let's just choose one of them. So at minus 2, 3, sorry, wasn't it? What do we see? Put the value in, 3 equals minus 1/3. X value is minus 2, so put that in, plus c. And that tells us that c equals then 3. And it will be, that's going to be plus 2/3. And when you move it over, I'm reading from right to left, so that's got to go over with the 3. So that's a plus there, and it becomes a minus 2/3. So c equals 9/3 is 3, minus 2/3 gives 7/3, isn't it? So then y equals minus 1/3 x, which we've got here, plus c, which is 7/3. And that tells us then multiply through by 3. 3 of these equals 3 of these, which is minus an x. 3 of these plus 7. The 3's cancel, that's why we're doing it. So we times by 3 there, all the way through the equation. And that implies then, move the x over to be with the 3y, x plus 3y. And also move the 7 over, flip the sign, becomes minus 7. There's nothing left over the other side, so it equals 0. And that's what we wanted to show, wasn't it? Now we need to find the equation of CD. So let's go back to our diagram then and put that in and see what we can work out from here then, shall we? So we've got the point C, the line through C perpendicular to AB. C has the coordinate 3, 8, so let's put that in. 3, 8, so let's put it up for illustrative purposes. We'll put it here, say, even if it isn't, but just for, so that's the point 3, 8. We're not drawing it to scale. And then we've got a line perpendicular, so I'm going to draw through the perpendicular line now, if I can, do my best. Here it is here, more or less. So that's the line perpendicular to AB. It intersects AB at D, so let's mark that point off there. And we need to find the equation of C to D. So if the gradient of this line is minus a third, this line must have a gradient of that times minus a third is minus 1. So what times minus a third gives minus 1? Well, we can see that the gradient will be 3, because 3 times minus a third is minus 1. So from that then, now that we've observed that, we want to find the equation of the line CD. We know it goes through 3, 8. We know it has gradient 3. So without further ado then, so line, if I can write line properly, what was it, C to D? Right, so what have we got? We got C had coordinate 3, 8. Here, we said the gradient was 3, didn't we? So y equals 3x plus c at 3, 8. Put 8 in, and then that's the y value. The x value is 3, so put 3 in, plus c. That's 9, so c will equal then, reading from right to left, the 8 can stay where it is, the 9 comes over to be with it, so it's minus 9. So c is minus 1. So y equals 3x minus 1. And we can rewrite that in an alternative form. Move the y over, 3x minus y minus 1 equals 0. So either of these represents the equation of the line, doesn't it? Okay, good. So that's the equation of CD. Great. I can just quickly have a quick look. Minus a third, so the line CD 3, 8. Did it go through 3, 8? Let's just have a quick look at the thing before we move on. Yeah, it did, and it was of gradient 3. Yes, that's fine. So it went through 3, 8, and it was of gradient 3. So we put that in, then we put in 8 and 3 as the x value and the y value. We got c as -1, and we wrote down the equation.